Hello and welcome to another video where we go over implementing this VT500 series parser state machine thing. I've got some other ideas that are slowly morphing into, and so yeah. The weather where I live has been a bit average last week, so I've actually done quite a lot of stuff like at home. Well, in the main house. This is like a little shed out the back, which I don't go out to in bad weather because it's uncomfortable. Anyhow, but yeah, so the moral of that is I've done quite a bit of work in the background. So what I thought I might do is start off with what you can do is we can get a log between like where origin main is and yeah, I think if you do 3 dots it'll just magically do it. Otherwise I should have done a dot on this side and it would have done what I wanted, but 3 dots I believe just magically works it out. I should read the docs again on that. But anyhow, so this is just all the stuff between what I was doing. Maybe we can do a one line on that because we kind of need to one line commits. Kind of looks like it. And what I can do is then go reverse, and it'll reverse the order. And then what I can do is do plus or just minus p. And this is all the stuff that I've done. So what I can do is just kind of slowly go through this mouse scroll. So I might just do that. It's a bit nicer than tapping on the keyboard a million times. Otherwise, I'd like you can do a few different jumps and less where I am. But I don't know if this works. It works. So this first commit, what I was doing is basically changing this log message to include the input that it kind of came on. And so yeah, so I got input there, and then we have this fprint_c input, which I'm not sure I actually defined in this commit. I did quite a bunch of stuff, and I didn't commit as I went, and I have now just kind of spent a bit of time like kind of condensing it down into bite-sized commits, but it will kind of become clear as it comes through. And basically this was a kind of dirty commit. It touched a bunch of case points there, which maybe I'll jump a bit further. This one, I add the C array len macro. So what this is doing is basically if you have a static array in C, and you want to know the length of it. Pardon me, I'm going to sneeze, and I don't know how to mute this. It's good. It's good. I might sneeze. But yeah, so if you have a static array and you want to know the length of it, depending on the type of the element, the size of array won't actually give you the size of the array. It will give you the size of the array in bytes that it would take up, which isn't really the length of the array. So what you need to do is divide that by the size of the first element, so how many bytes the first element takes up, which is also as many elements as you want. And this star operator is safe even if you've got nothing in it, because of size of being a macro in itself, I believe, or like a built-in intrinsic, something like that. And so then I can just replace a few points like that, and there'll be functions coming in that will make use of that. Right, so this one I am adding, doing a bit of a refactor. So I had control function kind of being pulled out in this macro, I'll call it, which is basically a big case statement, which will have a case stat and switch when it is a switch on whatever, and then a case on that, and then this will be the what it executes. So now it's going to do that. And so because I've done that, pardon me, must drink water, very human of me. So because of that, I've changed the way the X macros work, where I had basically a thing and then the character value that is basically what control value is the input, and then what this is the function, and then they'll expand out to be a type through various means. And then this S is again the switch statement of it. And here I kind of change it and edit an L macro, which is basically the long text of it. So I can either get this short text, which is just the stringification of this, or I can get this, which is a slightly nicer string. And for some reason, I did not indent on the S to make that look nicer. So perhaps I can do that now. And so because of that, I don't really need this helper function anymore, because I'm going to actually handle it in the function, which makes it slightly easier to take the same concept and kind of only copy one chunk of code rather than 10 different chunks of code. And I do have like a kind of long list here, but that's all right. That will also get added to, as you will see. And then the execute kind of changes a little bit. So instead of taking a control function, it needs to work out what the control function is. And this is basically the value, what it was up the top. And here we have that big switch, and then there'll be a case, and it'll return the right thing. Otherwise, if it doesn't, it'll have this -1. And I think we could have potentially done that as a default there and not have this like weird -1 thing, but it's all right. You have like a sentinel value, and as long as you check it directly after and then do something based on that, which is this UNIMPL, which is in this commit is aborting, but later on it either aborts or returns, depending on which type of debugging you want to do. See all the things that fail, or just stop on the first thing, which could be a parameter, which perhaps I'll do that. I'll go through all this first, but yeah, so this is basically doing the same thing for the CSI functions. So CSI dispatch, instead of taking the function up there, it does this. And I've actually added a few functions that don't exist in this, but it's basically doing it's the same as what this is, and then another function that does fairly similar, and it's basically panning out. And the private tool doesn't exist, but just ignore that for now. But this was basically a refactor to kind of show how these modifications took place. And I mean, I did it, should have committed at the time, but sometimes you do a few things at once and then you're like, cool. And then you have the long functions as well. And then so we'll use the keyboard. I'll put a line up there. Right, and the dispatch, so here we kind of shift the print statement down to after we get the actual function. So instead of taking the function, we take just the character input, and then down here we do that, and we chucked it a few more functions just to ignore that. And here we stopped on the last video, I believe, on the collect action, pretty much. That's like you do an escape sequence start, so the escape square bracket, and then you push a space or a question mark or something like that. Currently, before we weren't doing anything. Now we can do a whopping 2 things. And I've also kind of introduced this sequence state structure, which just kind of ignore that. Well, don't ignore it. I've kind of pulled it out for a reason, which means that the clear function doesn't have to kind of keep up with how many things are in the actual VT structure. Now we just have to care about the sequence state structure, which has this stuff, and we can just clear that whole thing rather than clearing things individually one by one, which makes things a little easier. And then the collect basically does this. And here we have like a little method. So we only allow two things, which the document does actually say in the collect. Digital define stuff for 2 characters and other things with 1. If more than 2 intermediate characters arrive, just flag that. And yeah, I abort, but it is what it is. And here I also sneakily added a couple of control functions in the last commit, and I just added them there. Now I'm adding escape function, so we didn't have any before. Now we're kind of adding them. Here, I've got this shift thing. I didn't actually do it, but I'll kind of talk through that later, perhaps, how that works. But I've just implemented a couple of things just because you can, but these functions don't exactly exist in this commit. But yeah, as you can see, it's kind of like you add a few things here and there. But it is roughly just copy pasting stuff and making sure you get the renames right. And ta-da, you have a new thing. So this is pretty much the same as the CSI dispatch, probably. I just copy pasted and ta-da, I've got a thing. Which makes it quite easy to now add like all the private sequences, well, not all of, I add a couple of things. And here you can kind of see like the tilde thing. So like if I maybe get out that, if I go cat -v and I push, I don't actually know how to do it on this keyboard I'm on, I'd have to think or pull up a diagram, but you can see here it did like an escape, which is these 2 characters, and then the CSI sequence and an argument to the tilde function, and the argument is kind of what this C value here is, and if we had 0, which I couldn't find any documentation for anything with a 0. Documentation for these private functions are kind of hard to kind of search for, I guess, but perhaps if I find it, I'll be like, cool, this is where it is. And this also kind of talks about the alternate buffer. Ignore that for now. The later commit will kind of talk about that. But you can see it's not adding that much, but it's we kind of defined everything up in that first list up the top here. Like this defines everything. It defines the character that you're meant to do. It defines the enum type. It defines the text that you might want to print. It defines the code that you're going to run. And all these statements kind of refer to that in some kind of way. And then down here, this is just another copy paste. I should do it twice because why not? And in the CSI dispatch, now we kind of check what we collected. And if we collected the question mark, then it will do the question one. Otherwise, there was a CSI, the tilde one will go to the tilde one. And then now I'm going to kind of talk about the alternative buffer, I guess. So here I kind of pull everything out into a buffer and the cursor is in the buffer, and then you can have a save cursor. And this is the pointer. So you might not always have a save cursor, but sometimes you do. And here you have a primary buffer, which is not a pointer, and an alternative buffer, which is a pointer. So sometimes you might not have an alternative buffer. And that kind of condenses a lot of this stuff down. So in the main VT struct, less stuff is in it because it kind of outsources it to other structures to store relevant parts next to each other, which might not be the best layout in memory, but it kind of is a good layout for code readability, which I think is kind of better in the long run, because perhaps this will be running in 10, 20 years, 30, 40, 50, who knows? I'm implementing something based in the 60s, so who knows? It could go quite a while. This one here, so basically now at the start of everything, instead of checking on, like we were checking VT cursor and VT cursor and VT cells, now we kind of, at the start of everything, we get a buffer, which is either the alternate buffer if there is a pointer, otherwise it's kind of a pointer to the primary buffer, which is a way of doing things, but it means now we just have a pointer to a buffer, which means this is the buffer, and it's never going to be null because the pointer to something that is in a structure is not going to be null. We know where the structure is, and the structure is not null. We've checked that, and if we return alternate buffer, we check it that it's not null there. So easy. If you push delete key, that kind of goes to print, not to the control, which confused me for a second, but there is actually a comment saying that it's unreachable, I think. Or perhaps I've added one now. But it depends on kind of what's mapped in, which I haven't really got a concept of mapped in, but it is what it is. And I think this is roughly the same. We do kind of call to VT scroll, but just assume that we've got a thing that scrolls. We will implement it soon. In VT action, again, we just get a buffer and everything, and now we can kind of show the commented out stuff, but this was showing a bit more stuff about the stuff. And soon I might condense these logs into something that can display on the screen, like as a gutter line down the bottom or something. And there's another thing that I also want to be able to show. This commit here, we're adding child handling. So now we actually have the ability to go to the extreme of even running like bash. I don't even need to do the no RC here, I think, but I'll still redirect things, but I'm now running bash and like it works cool, and I can kind of do the things that I could expect. So can run reset. So if I had UNIMPL, which I can change, if yeah, that one there, and then change that to false. And if we run that again, perhaps if we reset our original terminal and do that. Now if I go reset, ooh, kind of reset this in a terminal, which is kind of cool. But yeah, so that's kind of a useful thing about having children. So if we have a child, we have to do a couple of things. So I kind of store a termios, which is like how line buffering and stuff happens, and pretty much I have the termios the same as what the original one was. So whatever we go into as, that's what the child thing would see. So if we run bash, it would kind of see whatever we had, which perhaps I could demonstrate if I like flick that thing back to aborting and then like do something that aborts, and then would be in that weird state where like new lines, often it's new lines, and then if I go back into it, I'd probably see that same thing, and like echo won't be on and stuff like that. And when we get signals, we need to check out for sig winch, because when we resize, we need to resize the model that the child also has. So the child has like a window that it kind of sees, and so we have to kind of actually do the IO-CTO, so IO control, and basically do what seqs does, but because we don't have the there was some reason why we couldn't, I think, but perhaps there isn't. But also, if we have a child, we should also kill the child with the same signal that we just received. So that sounds fair. And same with SIGINT, we basically do that. And I think I decided it would just kill us at some point, but I could go back to another point where it doesn't. And then we could also receive another signal, SIGCHILD, or SIGCHILD, because, I don't know, sometimes in some places it has a child there defines, but in other places it doesn't, like SIGCHILD. But if you get that, that means a child has died, which is quite sad, but it means that you should then wait on it. But with this option, no hang, which will basically say return immediately. But we already know that this should be the case. We may get an error of eChild, which means like it's already been reaped, I think is the term for it, which is the reaper has come along and pulled it up. Which means that we can't wait on it to find out the information. And I think this is kind of an unreachable case for us, because it should only really get reaped if something waits on it, I believe, and we wait on it here. And I don't believe it's waited on it elsewhere, but I could be wrong on that. And if it's another error, we just kind of say what the error is and return exit code. So if we return like add positive number or 0, it will then return the actual program. If I return -1, babies just don't ignore this signal. So sometimes this signal is ignored. Pretty much if no error happens, sequence is ignored, which is a good thing because that's resizing the thing. So this, we do that, and then we kind of return with whatever the child returned with, and we check if it's the signal and do the whole 128 plus sig. And cool, that's that. And then in our little signal FD, we also check for SIGCHILD or SIGKILL. Now, you can't actually check for SIGKILL, but it doesn't complain if you try and listen for it. So, may as well listen for it. And that's in the case that you don't have a child, which would be if I just run that, and if I do, I think, yeah, if I kill it with a SIGINT, it would, it selected on that signal, and it got that, and it returned. Easy. And easy. That's because my standard error is kind of coming out to the same place. That is all good. So here I kind of have some checks to see whether things are closed or not, and that's just to save a syscall out. You can kind of check with fccnto, file control. Maybe it's just file control. But yeah, here we used to actually wait in here, but now we do that wait elsewhere because we're waiting for SIGCHILD. So we did actually have some kind of notion of a child before. Easy. It's a lot more fleshed out, and it kind of works pretty seamlessly. And here I don't need to do all this, like if one's like left out or not. I can just kind of select on all of them, and the select a couple commits, I think, will kind of change into a point where this will check whether it is a valid file descriptor or not, and it will only select on the ones that are valid. If it doesn't do that check, it will just error out every time. So you do kind of need to know, but And I think because of that, we could almost change this into a count, and when we reach a EOF, we just kind of increment it by 1. And when we get 4 or 1, we break. Cool. So this is a bunch of debugging kind of stuff. And if we have sig child, that means that everything should kind of get cleaned up. To do that, we kind of yoink this out into a while true, but it's roughly the same in this unit, I believe. Yeah, roughly the same. We had like an option that if we're running a child, sometimes we want the standard error to kind of appear on the screen, could be useful, and sometimes we might want it to not, or go to just the true standard error, which could also be useful because then you can output to a file. Perhaps it could be a config flag, which we don't really have a config flag yet, but yeah, that's that. I kind of make a new function for setup child, which does all the pipe stuff. So there was pipe stuff in here, it's now up there. This commit looks a bit gross because it's doing very similar things, very close to each other. But pretty much I pull out all that stuff from there into that, and then start main, and then that's kind of the stuff that it was saying and was taking out up here. This kind of pink stuff, it's like it's kind of gone, but it's also not gone. It's not the same as this red stuff, which is also kind of gone, but yeah, it's just how diffs work. Diffs got like more complicated than it used to be, I'll tell you that. Cool, so I've even got a little note, maybe do some arguments, could be cool. So that's that. And now I add all these functions that I told you I was going to talk about. So I add this VT3 because now we have quite a large structure which could have a few different pointers. So we go through and check all the pointers, and some of the pointers might have pointers itself. So it goes through and does all that. And this VT3 free is actually used as part of the reset code. So there's like a reset code if you go escape C, which you should be able to just kind of just go escape C. If I do escape C, right, escape C, Alt C would do it. Maybe bash catches it, but that is the code. Live demos there. I thought it would work. I had trust, but yeah, I understand why it might kind of get captured, because you can't capture and kind of emulate what it would do and what it wouldn't do. So this all kind of does that, and it kind of resets it into a kind of same state. This scroll only does up and down, because the left and right you can't kind of just take chunks of memory. This is kind of taking a row of memory at a time to kind of yoinking it up. I believe it has to do a row at a time, because if you try and take like that and that, it like overlaps. Maybe that's a better way. It kind of overlaps. And if it overlaps memcopy in the docs, says that it could do unusual things. Because the order might go from the bottom, which is now kind of, it won't get the right data. But if you go to this, you kind of control the data, and these two rows don't overlap, and then these two don't overlap. They'll kind of go down or up, whichever way you want to go. Here, draw window, it's kind of the same as what it was, but it kind of got moved up because it had to. If we want to print a character, I have a little helper function to kind of print the hex value of it, and then the character code if it has a fancy one, otherwise just the character if it's a printable one, otherwise it just doesn't do that extra information, it just has the hex value. Resize is kind of similar, it does some other stuff in the like replaying stuff. like I think it makes use of like, yeah, I don't know, yeah, it does kind of, it stores like this carriage return and line feed in the source thing, but I think now that I've got alternate buffers, I want to change how that read cycle is done, because docs say the primary buffer is normally used for just textual content that can scroll, which is kind of similar here. I have a textual buffer that can scroll, but if I am in, say, a full screen app, I haven't captured the mouse, I guess. But if I'm in the full screen app, it doesn't really have its own, like, if I kind of do things, it doesn't, it does. That's weird. I should be going in a different mode, but I think if I go into my trusty other one, if I go into that one, this one does not have a scroll back. Well, actually, it captures the mouse, so maybe that's not a great example as well, but is what it is. But yeah, I was trying to do something fancy there, but I think now I want to do something different again, which is kind of store a text blob almost, and then kind of replay that. And it can kind of insert in the carriage returns as it needs be, and then just replay it. Because at the moment it looks kind of janky if you have a well, I can kind of describe. So if I have something like this and it's got a few lines, and yeah, say if I maybe get some content on there. So at the bottom it should have this, and what it's going to do is it's going to start from the top and then just scroll down until it kind of looks right, and it did it reasonably quickly, which is surprising. But perhaps if I had like something on every line, and then like maybe we can control D by accident. Live demo over. Anyhow, perhaps I made it a lot quicker somehow, but I thought the scroll was visually noticeable, but even while recording a video, it seemed quite important. There's some spaces that I should clean up at some point, but it is what it is. And then that's kind of just moving the cursor in the right place and all that. It kind of does some things, but mostly it is the same as what it was. It doesn't really care about the alternative buffer if we've got one on the primary buffer, so errors will probably happen. Yeah, I'm not too sure what will happen there. But you kind of want it to. I think it just works with the alternative buffer, but then when it goes back, I'm too sure. The bell, what it does is, all it does is prints the bell character to the my TTY, which is like this terminal. And I had an idea of I can actually invert everything for like a second or maybe a tenth of a second or something, to kind of show a flash as well, which is similar to so if I go printf -a, it does like a very full screen flash, but just on the outside borders. We could also do something like that. That's a tmux feature. How do I want to do this? I can just probably go something like that, yeah. If I then go printf, do that. It does here as well, so maybe it was in the st feature. but it may not do a visual thing. It may also ring an actual bell, or maybe just do a beep on the PC speaker. You're not to know exactly what this is going to do, but this is what it does on terminal editor. I guess I thought it was a Tmax thing, but I guess if it was a Tmax thing, I would just do pane. If we get a backspace, which is a control character, which is potentially not what is the key that will happen if you push the backspace, which is kind of confusing. But I think it's control H from memory. But if we do this, we also have this request emitted key. Ignore that for now, but it will become obvious in a second. Cool, so this is that. All it does is, as per the docs, goes back one unless it's on the first row, in which case it does nothing. And if it changed, it sets dirty. I could potentially make a macro called dirty, which just wraps code, and then you put code inside. And yeah, I don't know. Line feed was basically doing what was just in the S bracket up above, but now it had to get pulled out because I'm getting the buffer and whatnot is going off just VT before, but now it's got the buffer, so I'll do that. Current return, same kind of thing. Save cursor, we now have this save cursor I kind of talked about earlier. Now we kind of allocate space for a save cursor and then kind of copy the old structure into it, which the compiler didn't complain about, so I assume that it's doing a copy of each of the values. Cursor is just like an X and a Y and a couple of balls, so it probably fits in the space of like the registers. Maybe even just one. Who knows? Here we move the cursor, so I've changed the up, down, left, right to well, let's move cursor offset with an offset of either the X offset or a Y offset, but this function could get called with both, I guess, and it handles both. And it gets the right buffer, checks various edge cases, and make sure it doesn't go off the screen pretty much, and then sets that and checks the wrap pending if we're at the edge. Which I wonder if I do actually run that, because like it's not really wrap pending because we moved it there. Can do some tests on that. In fact, easy test. We can just run this without anything, and if we just go, we also output stand the arrows somewhere. If we go all the way to the edge, so I'm going to go more. If I push a character, I believe it will push me onto the new line. Yeah, so I think I don't want that there. I think I found a bug. I moved cursor, that one, and get that, and we also here don't want that. And perhaps search for rep being equals. So when do we set it? I think that's appropriate. If it's just those places, awesome. Bug fixes while looking at code. That's what code reviews for. Just reviewing my own, but that's what it is. Alternative buffer, that's kind of cool because that's when you kind of bring up a whole new screen. And so, for example, if I go get my log here. Cool, it's got some output, and for example, I can only scroll in here unless won't let me scroll up, but I guess it's taken them out. But I quit and it's back to just here, and I don't see the output there. And I guess another one is Vim, and Vim's also got some things. If I go set mouse equals nothing, yeah, that just gives it back to Tmouse. But you can see here that we type in some stuff. We've changed state, but the previous one is not us, I guess. It does mean that I need to go into the alternative buffer for my application, but also have an alternative buffer inside the alternative thing, because I'm emulating a thing with turtles all the way down. So alternative buffer, that does that. Ignore the key stuff for now. Here we check whether we're turning it on or off. We could potentially call that a macro, just so if I read the code later, I know what H and L means, but H is when you set it high and low, I guess, but they're just the terminator keys for like a thing, mind blank, private CSI function. So you got CSI a question mark and a number, and then H or an L, and the H means turn on that thing, or an L means turn off that thing. Cool. But yeah, perhaps I'll define to say what an HL was, or perhaps only passing in that, but I don't know, it kind of talks that there, but that's all good. So if we're turning it on, if we've already got one, cool, just return what it's already on. If not, we allocate space for one. If that failed, just return we couldn't do it, whatever. Then we copy the buffer, the substructure, the buffer that we had, which we can get a pointer to the primary buffer, and we just need to get the size of the alternative buffer, which is like, this is kind of cool. It's just copying the existing stuff from within the structure, but only the relevant part. And then we allocate cells for that because we need to have the same kind of width and height. And if we didn't get any cells, then we should free whatever we did and just kind of reset everything back to what it was. Otherwise, we should make sure we don't have any pointers that are floating about from the old one. And so basically we don't have a saved cursor, and we set dirty. So it will redraw this buffer, which is now the current buffer. And if we're turning it off, if we don't have one, we're already done. Otherwise, we free it, but we can check for all the sub things and kind of free all that. And then we set the primary buffer to dirty, so it redraws. Reason line, that did like either from this character onwards or this character backwards, always including this character, or just the entire line. And the reason page does the same thing except for screen, and always from the cursor, including the cursor if you're going forward or backwards. And that's just easy sets. Here, this is kind of the draw window that we kind of pulled up from below, and we had to do that because we wanted to reference it because C's like that, and we don't have any forward defines. So this is where I add keys, which might make some things a bit more sense. We have a none value, so zero initialize kind of makes sense. We also have a request value, which could have been a boolean, but I decided to just kind of add it into this because we already have that memory kind of used up in the structure, so why not? And then we have a raw, which just means it's whatever character you kind of store alongside this value. or it's one of these kind of special ones. And there's like more special ones that I could add, but these are the ones that were on my laptop keyboard while I was working. So I thought that was sufficient to kind of show off this thing. And here we have some modifiers, which we don't have modifier parsing completely done at the moment, but this one also needs to have a particular value, so I use an E macro. So if there is a thing that requires E macros, we kind of set the value to this rather than just have incremental stuff. And that means this shouldn't have a num macro, I think, but I think it does. Yeah, so that one might be a little interesting about that. And so now every time you push a control, like when I do a control C, for example, I'm actually sending a byte 3, the byte 3 or 2 maybe. How do we want to do that? So because of that, you kind of control can get told what the key is, but some keys might be a bit different. So tab is something that gets sent, and enter is also like a thing. And you see it's actually kind of using up values that probably mean something else. So I said 3 was control C, and you see here the code for it is killing with a silicon, and they'll fire off to the read handler next time it comes through, and it's all pretty magic, and this should be pretty performant, I think, if I get the redraws doing good stuff. But you can see here that tab and enter are kind of on the same thing, and like even escape is kind of there, and like that's just the escape key. Like that's what happens when I push the escape key. But what happens if I push Control C? That's like 03, and we can kind of see that if I do. Yeah, I can do this, and like I can go like Control D E. I'll do Control R. Control E. Oh no. If we do that, we can see we sent a 12 and a 5. And so my thinking is, what happens if I send something that ends up being a 9? So if E was 5, we want to go F, G, H, I, and just formal, so H, or I. But if we go Control H and Control I guess I did Control I, but tab hadn't created that. I'll do tab again, and we'll go Control D, and you'll see there that 9 is just a tab. So if I go Control I, it's just always a tab. And the same for enter, which is D. That is actually Control M. So if I run the Control M, that's enter. Same action. Control J is another one, but that's just for line feed, which I haven't put anything there, but that's because it doesn't really correspond to a key that I can push. I have to push Control J, but Control M, I can just push enter. So if I do that, Control, I was pushing the wrong one. If I go Control M, Control J, then one done that wrong order, and then enter. Because I have terminos enabled, it all came through as that, but they were actually different characters. But in my one, so if I go here, and if I go Control, it doesn't have. Yeah, it's got VT, J and N. So you can see M is doing that carriage return, and J is doing the line feed. And then we do that. And if we get emit from EMP, which was where the standard error was going, we get nothing. If we just like that, then Control J and Control M and enter, and we also got an X in there. And now if I go that, we can see my thing actually parsed it. We did Control J, we did Control X, and we did enter twice, even though I did Control M. And that's because I have declared these keys specifically in here just for those. These were kind of defined before. Here I have to get the sequence state, kind of pulled it out, and that made for the reset easier. Here we have CSI functions, so when I pushed up, down, left, right, these were these keys, so I kind of put them here. And these K macros, which I'll call them K macros because I guess they're called K, they allow me to do some quite cool stuff in a bit. And the tilde functions, again, if I push F, this doesn't have the F keys here, but there'll be, some will be in some places, some will be in others. Here we can push the home end insert things, which are on my laptop keyboard, but not this one. I wouldn't know how to hit them, but I could do the tilde functions that do that. And so like if I go escape bracket question mark tilde 1 and swap the tilde and the 1, it would do a home. It would be the same as if I push that key. Cool. And so similarly here, the because of the E stuff, I had to do this E macro for modifiers, but the rest is similar. We have to declare K because we don't use K most of the time. A few things we don't actually use as these strings because the action log was quite busy, and we had other logs in other places that did things, and the key and modifier, I have another function that will do it a bit nicer, which I potentially could yoink that up. Oh no, see, yeah, why I couldn't yoink it up is because of this key raw business, which yeah, because it had 2 parameters. You need to pass it that key raw. Unfortunate. But yeah, that's kind of why I didn't use these, but they're there if I kind of want to kind of get it. And the shift lock stuff, I only really use it for keys. This is how I print all the keys, so it's either just a character or the actual textual letter, otherwise errors. We have this emitted key, which is just added onto the VT structure. And if it is set to a value request, that kind of means that we want to know what the key that was pushed down is, rather than do the action that it would be if it was a real terminal, if that kind of makes sense. And we're only really requesting the keys when we've got a child program. Otherwise, we don't request it, which potentially we do want to request it and to replay it into that. I don't know quite how I want to do that. Or just run through twice. One would request, one without. At the moment, if you run just by itself, like I was doing here, and like Control J, and like all these, it doesn't know any keys. Like it doesn't know anything about them. So this is where I do the shifts when we are in print, which perhaps I should do a little note here that if we have a shift down here, I don't know how to deal with it. At the moment, it just prints what it is, which I think is roughly what like xterm is doing, and like st, I guess. But yeah, if you push F1 to F4, it will output one of these codes. It will kind of do the single shift 3, and then in that single shift 3, it has kind of this. So this had to be a little ugly. If we're in 0, if we push the 7F, which is the backspace, we'll say it's a backspace. And otherwise, we'll say whatever it is as a raw. So like that kind of had to be hard coded. And if we had the shift block, we'll turn it off because we've dealt with it here, and then we'll kind of return from that. I think that should probably be unreachable, but I'm not too sure. So this stuff is stuff I should have done before in an earlier commit. It's basically because I moved it into a sequence state, which was so I could clear it easier, just to rename everywhere. There's some defines that kind of get done, but this is how I do the keys for a lot of the things, is I just kind of define this key function, k function, and if k is not none, then set whatever the key is to that, and then cool, we're done. And it clears any modifiers, this thing, so it will just be that key, no modifiers, and that is roughly how I want to do it. And the modifiers, they'll get kind of parsed in a different way. And if we are in execute and it's not a control character, we probably should complain about. Otherwise, we can say what control character it is, and that means that this formula here is valid. Otherwise, it wouldn't be valid. And we always return, which is potentially what we should be doing up here, always returning. But it's kind of, I don't know how to handle other cases, but and then we kind of have to undefine k and redefine it to nothing for the rest of the function, which was making use of these lists that have a k macro in it, and that means it'll be blank, which means this will just be what it was, and that's the magic of it. If we have an escape character, it kind of means that we have pushed Alt, then that character, but it could also be an escape, then that character. But in this case, we're saying this is what it is. It's an Alt, and if we are a control character, then it's also control. Otherwise, it's none, which is 0, which won't change from the Alt. And the key will be whatever it is. And the raw will be, depending on whether it's a control character, will be that same formula as above, or it will just be whatever the key is. And that way you can add control Alt something, and you can capture that kind of key there. And then here, this is in the tilde function. So if we have extra parameters, more than one, then that means we have some parameter modifier information, but at the moment I haven't implemented that, but I could. I just haven't yet. Here we have a very similar thing, so that k thing was just copied from above and kind of adapted here, because this might have 2 parameters, otherwise we just get the 1 parameter which was passed to us. Easy, and the question, the normal dispatch have a very similar key function, and very similar. Here in process, we do a few hard-coded things for input things. So if we are in escape and we get an escape, normally that would just put us into escape. But if, like in Linux, or at least on my terminal in Linux, if I push Alt escape, I will get 2 escapes in a row. As kind of one packet, so a read of any buffer over 2, it will capture those 2 bytes. But if I push escape, it will likely come up as 2 packets of 1 character, which we kind of handle in other places. So if we get a carriage return, which would be an enter, we will say it's an alt enter in this case. Otherwise, we'll kind of deal with that. And that's just because these cases have anywhere transitions, which are kind of shown on here, like anywhere can go to here. So anywhere in escape will go to there, and anywhere one of the controllers, the 1A, will go to ground. Anywhere. So those are the two things there. If we did that hack, then we do that. Otherwise, we continue on with the processing of it, which will exercise the state machine. Here, when we're reading input from standard in and like replaying it, pushing it through the state machine. We'll push it through the state machine, but before we process anything, we'll set key request to key request, and we'll make sure the state's in ground. So any time each character, each start of a key press will start in ground, so you'll capture the full sequence. That's the idea of that. So it's like a little different here. We're kind of changing the state machine slightly just for this case, but it's kind of resetting the state machine. So then we process the character, which will do this thing. And then here, if we don't have the key request left there, that kind of means that someone set a key. So that's going to be our key, and we emit the key, and we say what the key is. And then we clear the emitted key, which will kind of reset it, and it'll reset to none at that point. And so at this point here, we can either exit the loop or continue round. If we continue round, this would be none. So it would be like, cool, I got something. I will reset it to request and set it to ground. If it's in the middle of a CSI thing, this won't exercise, so it won't get reset. And so it will still be set to key request. And it won't do this bit, and it'll continue on with the sequence. So it kind of captures the entire sequence, gets a key press, says what it is. But it still kind of processes it, but the functions don't really call. So like it doesn't do, if you do a cursor up, if I do it here, it will kind of move the cursor, but if I just run it in cat, it will kind of change the output, which is kind of similar. It does fairly what you would expect for a child, but it also captures what the key is, which is useful debug information, which that's one of the things that I wanted. Then at the end of it, if we are still kind of requesting a key, it kind of means that we didn't match a key from the entire input that we pushed. And the kernel will only really send it if we send an entire packet, and we're not going to be sending more than, I think it was like 5 bytes. So it would be unusual to be, at this point here, it meant nothing worked out what the key it is. So if that is the case, then it's probably one of these 2 cases here. If we are in the escape state, it means just one escape character came through, and that means we probably just pushed escape. Easy. if we are in the CSI entry, it's kind of like a weird state because like we pushed escape, then that, and what is a escape character followed by another character earlier above that was the same as an alt in that character. So that is what happens there. And I potentially have to do the same for the other entries, like DCS entry. And like if we're in this string, it's going to be one of these characters that went in. We don't know which one, but we could just say which one, I guess. If we're in this entry, then we know it's this. If we're here, we know it's this. And like we've just done this case. And even when we're in this case, like you don't really know what it is. It could be like any of these characters as a alt, but like these so like if I bring up the ASCII table, let me get here ASCII. So if I bring up this 20 is space. Oh yeah, so this like if I go this alt space to like 2F, alt space to like yeah, so what happens if we go no alt yeah, I want to yeah, so I can't really go alt that character. If I go alt this is kind of we can't really go there. Uh or like alt dot seems to work, and that's in the yeah, so alt dot, which it does something in bash, and if we go to here and do that and see what it is, we get the escape, then the 2E, which another bug. So if we go escape dot, no, we need to go into that one, escape dot. So if we do something like that, or like alt dot even, and then do that, and then if we do that grep, we just got CD twice. We never picked up this case. So I think I want to equals VT key request. I had one. Really want this one. I think in this case, it's like kind of weird. Unreachable, unexpected reach. That shit that didn't register a key. Key. Yeah, I think that is what I want. And then we don't actually want this match thing. It's just always going to match. And now I think if I do this and I do that, to that, cool. And I think in this case, I probably want to do like a different. I want to know what state I'm in. And we can state is going to be that, and yeah, I think I just want to see where the state is, and then if we get that, and then like yank to that, not to, but yeah, I got the right one. Easy. and then we can probably just do that again. And then now if I go Alt Enter, it will say we're in this state here. And by golly, that means that I'll be able to see like what I've collected and then know which key it is. Yeah, and in this case here, I don't know. But then again, like these keys are not in the ASCII range. So if I actually go into bash, but the other bash, yeah, this one. Yeah, so like echo is off, and I guess the new line is kind of funky things. But yeah. If I look at the ASCII table, that was what I wanted. So the ASCII table of stuff over 5 is these ones. All right. So what characters are these? 5, 8, 5, E, and 5 F. 5, 8 is an X. 5, E, hat. So we can see this. So if I go into just this one and Alt X, Alt Shift X, we get that and we see that we're in this string. But like, how do we know? I feel like this needs an action, right? Action collect. Just so we know what one it is. I mean, in reality, it should be 3 separate things, I guess, but it is what it is. And the 9.8 is not possible. In this, we stop at 7F. And that's just got the one that comes in, and that's just got the one that comes in. All right, so this one we collect so we can kind of see. I might kind of leave it as unreachable, but I kind of know how to attack it later. But so that is the case. We should always get a match in this case, and then we print it out. If we got to the end of this and it is not request, it is most likely none because we would have hit this one and then set it to none. In which case we set it to none anyway. So I feel like that's not actually required and like that's not required. But like perhaps it is. It's a small amount of memory to do a mem set. But well, this doesn't actually do a full clear either. I feel like this isn't needed. It's kind of, we know that we could even do it like an assert that it is none, and then we know that it was set to none there, and then that means any modifiers were kind of preset as well. Cool, and that's that. And then fixes was like kind of adding in all the stuff that would kind of leaked in that I didn't know where to put. But yeah, we like, for example, we get the attr. We don't actually need to set the attr if we couldn't set it. So like if we couldn't set it, it's just already what it was. We don't need to reset it back to the original. Here I only set it on S3 out for some reason. Perhaps that's so I can pipe stuff in, and I don't know what happens in this case. Perhaps if you're piping it comes in as raw anyway. Bash probably does that for you. And so here, I should have put that in another place. And here I actually found like missing cases in the state machine. Not from this diagram, just from me reading that diagram and not putting everything in. So I hit a couple in here, just pushing random keys, you know, that's how you test things. I mean, I could test it also by sending random bytes or passing AFL to it or something. It's potentially out of state that I could chuck AFL at and see kind of what it gets up to. And so now I kind of add in some default cases. Something is missing, just in case I've missed something somewhere else. Here I did that thing in the select that I mentioned earlier that I now check whether we actually have a file descriptor. So this is a file control to get the file descriptor. If we cannot get the file descriptor, we don't do this. If we could get the file descriptor, so if it's not an error, we do that set. And now here we also do the select and while it might get interrupted. So it might get interrupted perhaps by a signal, though perhaps not because, well, it might get interrupted by something. I don't know how signal FD kind of works. I don't know if like you actually get an interrupt at this point, but on the off chance I kind of do this loop here. But it'll likely only get called once. So here we also kind of check whether we have a file descriptor for it. Kind of weird on the way out, but just in case, and then we do what we did before. And here I kind of get back up to where we were. So what I think I might do is this editor like has lost the ability to remember where things are. So if we can do the easy ones. If it's a OCS string, OCS string, it is going to be copied too much, and this is going to be what did it reckon? It was going to be a 5D, and a 5D is where are we? That bracket, not that bracket, that bracket. That's nice. So it little closes that little pair. You can jump between them. Cool. Then we also have DCS entry. We're on to actually committing editing code. So we want that. No, I wanted that. Can just do that DCS entry, and so DCS entry had a 5-0, which was a P, and so we can just do something like that. And these are all when we're in escape. No, these are all like coming from the escape sequence. So the last key would have been the escape. And we shouldn't really be in any of these situations, like anywhere there. But these two cases we do kind of need to care about. So escape intermediate. Case VT state. So escape intermediate. This is a little trickier because, as you know, it's not too tricky. We have collected a string, so we should be able to, if T collected, but it was in sequence state code. So I think I want that sort of thing. So if we can't get it, we should have unreachable. No collected state to determine plus character, do something like that. Otherwise, we should be able to do like a that, and then we can just grab it out of. I just realized that. Well, I can just do that sort of thing, and then that's meant to be num collected. So we should have one, and is ambiguity. Ambiguity. Is that how we do it? I think it meant that it was weird. Oh, no, take me back to there. No, take me to there. Take me to, yeah, that one. I think that's a reasonable thing. Otherwise, it is that, and then we can break. And I think in this case here, just because everything was ignored here, just because these characters are ignored, I think we could adapt that to be a collect transition as well. And so here we should have SOS. If we don't have that, we can have the same kind of thing. And that we can probably do something like that. State CS, yeah, that thing there, and then find that, and then yeah, to that all the right way, and then do something like that, and we'll do that as well. State CS, just so we kind of know where we are. And that should be all the cases, but how do we get to here? We get to here at this point here. And I think we can, where's a collect? We can probably just take that and yoink that. Is that really where it thinks it should be? Not like anywhere close to yeah, so we can just do this collect and not an original diagram used to determine and plus sequence for these three, except not on these three. These three are the high ones, the 9 ones. So where else do they go? It's in this case. Really, is that where it thinks I should be? So in this case here, we want to have that. And does this happen anywhere else? No, only there. So I think that means now we should be able to go here and like what was some of the things. So these alt dot should kind of pick up and the 585E that was X alt X. So alt dot and alt X. Oh, we can't compile. All right. What is we don't have DCS string. We have DCS entry. But it's OCS string there. Perhaps this can come before that. Just I don't know. Right, cool. So alt dot and alt capital X, and we can do that, and then we can grab that, and then we got alt dot alt capital X, and then Control C to kind of kill it off. Cool. And what was this 50? And 5D, 50 and 5D. So if we have a look at that, 50 is P, capital P, and 5D. Was 5D, was it 5D? 5D is closing bracket. So P, Alt P, and Alt how do we do this? Alt closing bracket like that. And then if we do that, so I did both, which is kind of good to see. And then we can kind of see all the keys that are coming out. So that's kind of cool. I might be a goodie. I might kind of run this up a little. I'll leave that out. So this can be bug fixes on stream. Cool. Cool. So what do I kind of want to do? I've spent like an hour kind of going over what I've done, but I have done quite a bit of stuff. So the kind of idea is if we kind of table something out here, we can kind of run this, and this is not in that mode. What we can do is we can set the make thing to run, say maybe bash minus I. And if we do this, it should kind of come up in bash minus I. And we can see here unimplemented a bunch of stuff. So I turned the unimplemented macro to not abort. That was the thing that was in the get bash. So in here we have well, that very first line. We're basically changing a false and a true. So that's slightly bolded. And so now we can kind of do things, but I wonder, yeah, maybe we should kind of implement this CSI function M, which is actually the SGR. And because I ran it inside Vim, it hopefully shows me exactly where I kind of need to do it. Not quite exactly. It says it here, but what I need to do is go up to here and then search basically up for this block here. And it tells me that it's M, and it also tells me that it's 6E. So what I can do is 6E, do that, and then replace that with M. And I know that this is SGR. And we can go none, and we can do something like that. And I remember this, I wanted to maybe go down to there and do like E align, and then like I think it was that, and then do that sort of thing, and then find the S, and then there, and then not that far actually. Yeah, like that's way too far. I just want here, and then find the S, and then just get that, and then do that. And then this looks maybe a little nicer. I could perhaps take one space off, just because I had a space in the regular expression. Anyhow, what we want to do is perhaps go here, and then no, do that. Do this, and what we're doing SGR, and then we can probably do a select graphic rendition. Is that what we're looking at? So SGR, select graphic rendition. We'll look at that. So what do we want to do on this select graphic render? We can probably, not that, but we can probably do something like that, and it's just we can probably do something like that, and then do that. And we probably want to do something different here. I think I want to select graphic rendition, and I'm just going to pass it to VT, because it can have any number of parameters, well, up to 16, which is a limit. I don't know whether it should be that limit, but so we have all of this, and I kind of have a boilerplate for attributes, don't I? Attribute, that attribute, this attribute, yeah. So I kind of have this. So I think I want to change these attributes, which I saw in each cell. Kind of needs to be a list of attributes, I guess. Or, nah. I think I need to do a similar thing to this, which I wonder whether I can actually do that without this E code business. Because I know it kind of requires putting stuff in global state. Yeah, nah, I think I was wondering whether I can kind of increment something as I go. Nah, I can't think of anything. But what I want to do is maybe go back a few places. Yeah, so where we did these attributes. These ones. So I think these need to be not done like that, and I think they kind of need to be done pretty similar to wherever I was here, kind of similar to these here. So I think I want to have that and maybe replace modifiers with attribute. And then here we can maybe see the one after, I don't know, like this one's on this line, this one's on that line, and like the editor is meant to kind of magically do this for me. But yeah, anyhow, we can and I kind of want a code to go with this, and like we have a code of 0 to say go to here, and we can code of 1 which might turn on bold. It's something like that. I don't know. But we can perhaps start with this. So we can go here, bold, and so I want this to be 1 like that. So the idea is that you then kind of copy this line as much as you want and just make sure that that E kind of increments. I just wonder if you can kind of do that somehow with some macros. I wonder how, I wonder why. I don't really wonder why, but I wonder how. Cool. So now what I want to do is maybe yank that word, but then search for this, and then do that, and then do that, and then paste. Oh no! So take me back there, and then like take it there, and yank that word, take me there, and with that word instead, then attribute. Um, yeah, it's kind of interesting. Yeah, I think like this, like where's that used? It's only used there. And where is that used? It's only used there. And where is that used? It's we currently say it's unused. I think it has become unused completely. Because it just doesn't really make sense with these E ones, because like you have 0, 1, 2, 4. You don't have a 3, but if you pass a 3 to that thing, it would try and look up index 3, which would, I guess, give none. But these I think I have to handle myself, or have another macro code that kind of deals with it. But yeah, so I think that is kind of how I do that. And so when I deal with the attribute, it doesn't know about it. I thought I attribute. So when do yeah, I don't like that. Cool. So now we've just added M. We haven't actually said where it is, so that's cool. So that's there, and that's our only error. So we basically just have to implement this. I don't know, where's this? Sure. Where's yeah, maybe we'll do it here. So we can have that is not kind of what I thought I wrote, but my timing has been a little off. Cool. So in SDR, we probably want to check if we have that. And then if we so we have some sequence state, and in the sequence state we have params, and if this is not the case, then we want to go VT, and where do we store this attribute? I think I want to close that, and then like maybe go there and attribute. We store it in the cell, I guess. Where else do we store it? We have a cell, and we have a current attribute on the cursor. So the cursor is we need to get a buffer, and I think this I want to do a few things. We other this can be unreachable. Unsure how to deal with printing ships. We can just do that. Maybe it can be unImpl. Yeah, I think unImpl, because then it will go forward and it'll just act as if it wasn't shifted at all. Printing, that take it down, bike chatting. Cool. So what I wanted was this. Perhaps I can do that, and then we can come up here. So we don't have cells, is that correct? No, we don't really care about the cells. We just care about the cursor, which is in the buffer. So if this is the case, we don't have any. So if we don't have any, it's as if 0 was passed, which we potentially. Yeah, I wonder. SGR. So SGR has like a bunch of things, and we find the function. This no, that's this no. Yeah, where do you like? Where do you tell yourself? So it's a thing that ends with an M, which I guess an M was what was an M? We go here and an M was 6D, and 6D is 6A, B, C, D 14, 6, 14. So we can search for 6/14 as well. 15, 13. Go that way. Yeah, cool. So I don't know why I wasn't finding that one. Or even that one would have shown me. Cool. So parameters default PS is so any of the defaults will be 0. All right. I think I want to change this approach. So for size T P equals 0, P is less than that, and then P plus plus. And so at this point here, I want to get the UNIMPL 16 T param, and it's going to be the VT param or the VTP, and our default is going to be 0. And so I kind of want to have that like switch thing here, but maybe we'll get that and we'll go here and we'll search for that attribute list and we'll search for this. So what could I have? I've already got that C. So we probably need to do some undefines and redefines. So what I might do is def C. We probably we'll just let the compiler actually complain. Tell me what is actually defined at this point. So I want to C code is going to be case code colon maybe a space. And then we want to define X of code, and this is going to be the thing that it kind of returns back to us, which should be because of the E thing, which I guess in this sense we could just return the E as well. Yeah, I wonder how it's because I'm treating these as like you can have many attributes on at the same time, which kind of makes sense. But hard to know. Hard to know. I mean, perhaps I just want to have a bunch of state, and is it bold, is it faint, is it italic, and then the reset can just clear that state. Yeah, perhaps that's what I want to do. And then I don't need this E stuff. Take me just to that one. So I would want this to be down there. And then you find it on E. And just to the end, yeah, and then just add that back in. Cool. So in that case, I would probably want a switch type thing. So if I have this, then I get this, and I could print out something saying that I saw a boulder or something. Yeah, and that way you can see whether it matched or not. But then I guess the default could also kind of capture that. But yeah, what I'm thinking is we can kind of just do this. And no, I don't need to kind of push that out into some kind of a function VT. It's not really, it's just clearing the attribute. I thought that would, oh, I already had one. Okay. You can close, I guess. You can go down there, and then you can go there. Oh yeah, it's right up to the edge there. Cool. So I think what this needs to do is I need to see the state. So currently in our buffer, which isn't here, and more than one. That one was. So currently in here we have a cursor with an attribute. Is that what we want? Yeah, the cursor's like where we are. Seems like quite deep to hide where we are, but I wonder. So if we do some tests, so we can enable a thing like 47H that should enable an alternate screen. We go back, we get back to where we were. And in fact, like this, the scroll up, it doesn't have the scroll up of what you would kind of expect it does there, if it kind of makes sense. But then scrolls kind of do it separately. So if we kind of now kind of do I don't know, 41M, which will do some sort of color, we can do some high world, country world spaces, and then we see high world and then our prompt. So if we lowercase that, and now if we go 033, that one, and if we 47L that, so we turn off the alternate screen, I wonder what this will get printed at when you close off that, and it still gets printed in red. So what that tells me is the like the this doesn't actually have that many, so I might go from here and then kind of work off that. But yeah, kind of means that the attribute, like this attribute that I kind of had in the code, doesn't really belong there. It shouldn't be on the buffer. Shouldn't really be on the. I think it's potentially just on the actual. I'm really glad we've got that in between. Like it should just be there's somewhere here, and it will be whatever the current attribute is. Then inside the buffer, inside the cells, each cell will have an attribute which will kind of line up with this thing, which will mean that we do need to store it, which does mean that we need the E nonsense. So E0 will do that. And then E1 shift 0 will do that, and then I'll have IMPL just get lazy and do that. So then at this point, to reset, we can just go and set VT and where is it? What we call it? Current attribute. Current attribute equals 0. We don't really need to set anything too dirty. We should be quite happy with that. And I think this will be like or equals the thing. So like not that, but like it'll or equals that, which means up here we have the code. So we probably just want to have VT current attribute or equals the code. Now I think or equals the E of the code actually. No, or equals the code because of the E that will equal that. It won't equal that. It won't equal the C. So this code and that code are different. What you could call it. But I want to do an if type. So if it is set, we do that. Otherwise, we set it to nothing. I think that's what I want. And then we can kind of just do a switch on param. And then we can do VT attribute list. And then it will just kind of fill in the blanks. Then we don't really need EA there. Yeah, we don't need that. We just need the E's. Then we'll define it based on that. But we should probably we can do stuff like this, and then find that, and then yeah, we don't actually need that. We did need that one though. So in here we can do a default and then unreachable. Well, let's make this unIMPL. Unlimited RAM for SGR RAM, and it is just a number, and we can pass in RAM there, and then it can just tell us when we need to kind of add more things. And so I think that's kind of that. We could kind of span this out a little and then do a little print. Because theoretically we can print strings. Oh no, we can't because we took away that thing because of the ease. Perhaps we need a string. I'll just keep on adding stuff. I'll have label actually. Reset. And this is volume. I don't know, is that like kind of what I kind of want to do? I don't know. And so this will have bold and whatnot. And we can just add new things. We just need to make sure the E's kind of go up, but the C's don't really matter. And then if we could we that, if we didn't get it, we should have that, and then we can undo the and also yes, thanks. I think that's kind of what I want, and that's probably what I want instead of the equals -1 stuff. But no, I kind of need it because I want to use that later. Anyway, back to this stuff. So if we kind of compile that, what is it right about? Let's close a lot of these windows. So it did complain about that. So the well, do we have an under the coming up? We have it there. So I wonder whether this goes, yeah. And we can just kind of close that. Right, so we don't have anything current attribute. This is actually on the VT, I believe. Unused buffer, so we don't actually use the buffer because we don't need the buffer because it's not related to buffer. Statement might fall through. We need a break on the end of this. Cool. So that just got back to everything. Right. So we still don't know M. I would have expected that we most surely did know M because didn't we add M with 6E? I wanted 6D. All right. And then that should do the SDR stuff. And it's doing the thing. or I'm not too sure what it's doing. So if we kill that, kill that. So if we search with this, so yeah, I think I do want to get the names out of this somehow. Heck, 101. No, how do I get the name out of here? I think I need to do, ironically, two separate things. Um, and then we can almost just pass it like that, I think. And then this can go to std here, and you can do a break like that. And then we can undo our split. Need that, and then we can do that. I didn't really want to do that. This one's closed one. Can we set that to that? And then, yeah, cool. You still complain. L redefined. Can we unleft L there? Does that kind of complain about lots of things other place? We need to have X just kind of chilling about doing nothing. Okay, that means we also need to unleft X there. Implicit declaration of L. That means we need to just give L there and just have nothing in it. Cool, that does that. And so it gets into the state I do not know. So what we could do is maybe do that. So it's currently doing this. Currently waiting on us. But yeah, got STR code. We should. We'll just exit that. Got STR code that was up in here. We want to find that and also add the things. So if we get here, so yeah, cool. It just doesn't know colors. I think that's roughly what is happening. And so it's not displaying anything because don't know. But what we can do is add those colors. Yeah. So if we exit out there, so like we're kind of still in. So we add this and like foreground. Let's get the foreground 0 to 7. I wonder if we should say what it is. but we can call it just 0 there. That's that. And here we can, what are they? Red, green, yellow, blue. Red, green, yellow, magenta, cyan, white, magenta, cyan, white. Right, and then we probably need to do that, 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 that. And then like probably go here, and then that was not showing that, yeah. Cool. And that means all these E's are wrong. Might have a research to see whether you can do something to make the E's kind of work. We need one more. No, we want that. Yeah, one. Do something like that. See, it's kind of annoying because, like, when I add them later, though, because I'm doing it in a function, I can kind of get it there. Yeah. And then treating it would also be similar. Cool. I'll see if this kind of contains. So I think I just need to exit from there. So yeah, when we're setting an attribute from here, so we also need to have a similar. So we want something here, and we also want something here to actually tell our terminal what it is. And I think I think therefore I am. What I'm going to do is here we're not going to have this stuff because it's just too error prone, and we can just delete that and do that, and maybe go there and on go to the dollar, then find that, then go there, then D that. And then here we can norm a do that, but not on that line. So on this, what we're going to do is just store a number of parameters in this current attribute, which is going to have 16 of. And then the cell attribute, which should have there, we should also have up to 16 attributes there. And they're all default to none. But what we can do is kind of go through and add them all into a thing. And I think if we get something like, can we go over here? No, oh dear, over here. So if we go printf, so what was it that I was wanting to do? Yeah, so if we do something like 41M, then 37M high, and do something like that, we get that, and maybe we'll I don't know, 47 and 33. Yeah, that's maybe horribly a little more readable. But what happens if we kind of add in something else? Right, so it kind of resets in that order. What happens if we like kind of keep on adding stuff after? Cool. So it kind of does reset if you do that. So I think the way I'm kind of planning on doing it is the way I'm kind of going to do it. We'll let the compiler complain about that. But what we can do here is almost just set the number. I think I'll just set the number. And so we can just go VT current attribute of T equals RAM. And then like we can have this. Just to kind of see what the code is, but then we don't really actually care what the code is. Like, we don't really care about storing it as the enum value, because on output we no, I think I will store it as an enum value. So what we can do here is and we really no, so like I kind of want to do dynamic array of things, and I think I do want it as a so what I'll do is find out where they are. We don't really have a dynamic array yet. What I can do is quickly knock one up. So we can have we can define an array of a thing, and it's going to be a struct, and it's going to have a pointer of types, and it's going to have a size t size, and it's also going to have a size t capacity. And that's just going to be an array type. And then in here, we want to be able to kind of, and I'll have them as macros, but array append. And so we're going to take an array, and we're going to take in data value, and we might also have an array clear of take me back there. And if we get this, so what do we want to do? We want to basically take our dot data. Well, we really just can just do that equals 0, and then this can be wild false. And this append, we kind of need to ensure that there is enough size. Ensure capacity is something like that, and this one we can do over a few lines. So first off, we want to check if our dot capacity is, if capacity is equal to if it's random equal to cap, then we can break, because we're in a do while loop, and that means we can at this point know that we don't have enough space for it. So what we can do is our dot data equals what is this? I want that, I want this one. So I want to realloc. Realloc, and this is going to take our data, and we want to realloc it to the size of a element in our dot data times, and we're just going to set it to cap. Something like that, and if not our data, we probably want to break out of that as well. And at this point here, we can go r dot cap equals cap, and it actually capacity equals cap. And we probably want to do a mem set of r dot data plus r dot size. So there'll be kind of the end of it, which and it could be the start. It will be the end of all about the data. And at that point there, we want to set something to 0, and the size of it, we want to get the size of a single element, our data, and we want to multiply that by cap minus r dot size, which cap is bigger than the capacity, so that should always be positive. And then we clear that, and then we at this point here done. So we can while pulse to kind of clear up that array and ensure capacity. Cool. And then here we can basically do an array and ensure capacity of R, and we want to make sure that it has enough space for R dot size plus 1. And then at that point there, we can, in fact, this perhaps also we can spread over 2 lines, or 3, and then r dot data, which should be valid at this point. In fact, no, it might not be. If not r dot data, if capacity is, that's really going to be the error case, isn't it? Then we can break it there. Otherwise, we get our data r size plus plus equals whatever the data element is. Then we can clear that off, and I think that is all we need to do for appending. Cool. That is dynamic arrays. It's a cheap way of doing it. Well, it's not cheap, but at this point here, we can go array of VT attributes. Attributes. I think that's kind of what I want to do, and I kind of want to get VT attributes. So in here, this should be this one, and this is also used here. So we can go array. And because we got this array construct, we can actually use it in what do I want to say? It can also be used when you're collecting stuff, because at the moment, let's say max of 2, but you could have that, and in reality, you could probably have more than 16 parameters. But yeah, we'll see where this kind of complains. We'll only have one window while this complains. So it did have this. How do I want to do this? So the attribute did not have the E code. So how do we work out that it is different from last? So it's kind of like a set of attributes, which sets are a little tricky to kind of wing out pretty easy. But I mean, I can kind of check that the thing isn't already in it before you append. So what we can do is we can define a set of I kind of want to have an array contains, and this is going to have some data, and if an array contains something, we kind of just want to go for that size t I equals 0 as less than r dot size, and then I plus plus there, and then in here if r dot so how do we want to return this value? We can probably do something like that. If that is the case, so if our dot data at I equals the data point that we have, then we can ret is true. So we can start off with ret equals false. And do that. And at this point here, we can break out of one loop. And I mean, really we don't really need to do anything more. At this point here, we have everything. So if we have a set of a type, this is really just going to be an array of a type, but we're going to do some stuff around it. So we can have a set clear, and we can just call that array clear of the same set, and we can have it define set contains, and this is also just going to be array contains, and we're going to have it define set end, and we're going to have a set, and this is also going to have a data element, and this is also going to have the data element. So in set append, we'll kind of break this out into a few lines, I guess. So what we want to do is we want to have a bool ret, and we can do set contains, and so this actually had a ret in there, and we want to add that ret there. So if set contains, so we want to do ret, then the set, then the data, and then if ret, then we can break because it's already in the set. Otherwise, we can go array append, and we can do s and the data element that we want to append, and then we can close that off. False. Otherwise, we'll be going a long time. Cool. And that's set append and set contains. So now we have a set, easy. And so I think that can be a set of attributes. And the idea of doing this is I can now do something like define set equals in S1 and S2. And in this, we can so we want to kind of see whether everything in so if S1 dot size, so this probably needs a ret as well, and we can probably set that to false. There is a way to return in macros if you're using GNU stuff, which I think I am in other areas, so potentially I could use that. But yeah, so if the set sizes are different, then we can just break at this point with the false value already kind of initialized. Otherwise, what we want to do is kind of go over everything in the set, and they are identical size, plus, so they should be identical size, though, like signals and whatnot, though. I think I'm handling it enough that it should be identical size. So at this point here, if set contains, so we can't do that now. We can go set contains ret, just use the same ret. We can S2, and the data thing that we're going to get is out of S1 and the data element there. And then if ret is, we can just break here. So if it didn't contain that, Otherwise, at the end, we should just have whatever value was last in rep, which if it was true at every step in the time, then that should be true at the end here. So we can kind of just do that. Now we have a set equals. So there was another place we used this. So I think this will be a set. And then here, if we do this, if EQ, and we can just do that, and then set equals, and then we can have last attributes, and then we can also have a cell attributes, and we need to pass in the EQ, and then if not EQ, then we'll do this. And so that means this thing here needs to be a set of things. And I think we probably want to kind of initialize that like that. And last attributes was not defined. We can kind of find that now. Right, so here where we do this, I wonder if this will kind of work. No, I think I need to do like an array copy type thing, which I think I'll just do manually. So I want to maybe just do set layer cell attributes, so clear whatever is there, and then set copy. Yeah, I think that's what I want to do, and then cell attributes from that one, and we can kind of follow the same kind of thing of source and dest. So this can be set copy and source dest, and we can just call that an array at that point there. So this can be an array copy, and then array copy we can kind of define as define array copy of this to source. We want to first off array. So when we do the actually take me there, we don't actually declare it. We'll clear it here. We'll clear dest. Then we'll for size ti equals 0, I is less than source dot size I plus plus, and then here we will array append. We can array ensure capacity of dest and source dot size. That is how many we're copying in. So just make sure that we've got that much space, and that way that each append won't be adding on. So here we can get source data, and here we can get that element, and then we can append that. And do that, and I think that is, wow, oops, done. Cool. So when we do the set copy, that is what we do at that point there. And so here we we want to append to what we have, but if it is 0, we kind of want to, so if we want to append, we want to do set end of, that's our set, and that is our play. Otherwise, we want to set clear the whole set, which will keep the capacity, but do that, and then we should still kind of get that. Still complains about a lot. We don't have that. That's all right. There, no comma in the next one. Cool. That was apparently all I needed. This is just it's crapping out with ASAN errors. Fun. I've been talking a while, and this STR isn't quite working the way I thought. Though perhaps I can do this. And it's just 0 bytes after a 1 byte region. Yeah, I think when we do this mem set, we don't want to. When we do this, so we start off with 0 things in. We should 0, and we're testing 1, so that is false, so we don't break. We allocate some space, we get the size of what we want, and we times it by 1. So we should have enough space for one thing in there now. And size is still 0. So at this point here, we mem set from size the null byte, the number of it, and then cap was 1. So we're going to take 1 minus 0. So just cleared the 1 thing. We allocated 1, we cleared it from 0. Should be right. Capacity is now 1. Next time around, we try for 2. 1 is not greater than 2, so easy. We try and add 1. We reallocate to the size of 2 of a single element, 2 single elements. We get some stuff. We now try and set stuff from the first element, and then we get 1 minus 2. Yeah, I'm not quite sure why this is overflowing. It's 2 minus 1, so it should get 1. So it should just be the 1 of that. So I guess what I can do is if print f, and it's going to be something like %p, and then it's going to be I really just want size equals %lu, and cap minus size equals %lu. L equals %lu, that can be that, and mem set size equals %lu off equals, not quite sure what key I pushed there. Right, we are here, we're back here, off equals it can also be %lu. And so what are we going to kind of send to this? We're going to, we can probably just do that. Cap size is the best. Cap size. Allocated space was, so it was size, it was just ink to that is really not there. There. And mem set size is going to be this thing here, so we can probably get same sort of thing there. And then the offset was going to be so this is going to be r dot data plus r dot size, and then I'm going to pass this to her element 8t pointer, that whole thing, after we do the pointer arithmetic, and then we're going to take off event 8t star of just r dot data, which should hopefully get me what I want. And so if I do this now, I think I just need to run it. Right. What are we? We need std error there. Oh, and then this should just go again. So we got size is 0, cat minus size is allocated 1, mem set size is 4. So alloc is only 1, but we're for some reason setting 4. And what is just this thing then? Our data. That's what we want there. Cool, and then that should go there. So size of is 4 bytes. So why is alloc only 1? So alloc is 1, 2, 3 from the back. So 1, 2, 3, and it is just the same thing as that. I feel like that should be 4 times 1. Like at this point here, what if I just put cap at the end? Does that change this 4 to a 1? If so, why? How does integer arithmetic work in this? It does. But because cap is just like 4 times what is 1? It's a quarter. How do you represent a quarter in an integer in C? I don't know. What I can do is do something like this and pass it to I mean, why? In fact, actually, what if I do it on that side? Does that make a difference? It shouldn't, but like, it does make a difference. All right. And where else do we use it? We also kind of want this thing. And that. All right. Learned something about C. I might look up why that is the case. Cool. Still seqs. That was after we got past one though, and then we tried to write 0 bytes after a 5-byte region. Love it. Is that what I want? No, just writes. I don't know. I think I might leave this because it has gone on a bit. But yeah, most of it was just talking about the new code. But yeah, a couple new features. So like another language would be helpful because you just have sets working out of the box. But yeah, for some reason this is not working. But that is what it is. Yeah, kind of interesting that. But yeah, I'll work it out off screen and kind of do things up. But perhaps I'll have a look see at what I have done in this. But it's pretty much just that. Okay. We align things. This we also let me just look at it. So here we align things, and here we also align things. Here we also align things. And we'll modify those attributes and do a few things. And we add some arrays and sets and whatnot. They're not currently working, but they will eventually. And theoretically, we're kind of doing what it needs. Like we append to the set and we, yeah, cool. Yeah, I'll just do all of that. And we can start of SGR stuff. Maybe push that up. But yeah, I'll work out what's happening. Might be a while because I've got things to do and whatnot. But yeah, kind of interesting. It is what it is, though. C for you. It could be like an alignment thing that it's like pushing out by like 4 because that's just what it wants to do. Hard to know. Anyway, thanks for watching and hope you'll enjoy and have a look at some other videos. Lots of stuff. Enjoy. Have a good day.